Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
In this last video about constant acceleration, we still have our three equations, but we want to talk about what happens when you have more than one dimension. Primarily when we talk about basically, if you will, the x and the y plane. The thing that's important to understand when you're doing constant acceleration problems in multiple dimensions is that they work separately, okay? That you have to do the problems in the x direction and you have to do the problems in the y direction. So you have to have two tables. So again, if we've got our table, remember the table from the last couple of videos, you've got x, I'm going to change the numbers a little bit, x1, x2 are beginning, final, v1, v2, a, constant accelerations, there's only one a, and t. And then you would have y, and this is vx here, right? And this is ax. You'd have y1, y2, vy1, vy2, a, y, and t. Now, the thing to really keep in mind when you're doing these problems, the things that connects the x's and the y's is the time. So the x direction and the y direction is different. The velocity in the a or the initial velocity, velocity and the final velocity are going to be different from x and y, but time can't. See, time is like the thing that connects it all. You can't. So if you know the time here, so this, if you know this is 10 seconds, this has to be 10 seconds. They're always going to be the same thing when you're doing the problems. But these other numbers can all be independent. And frankly, what usually happens, and again, this will come up in the subsequent videos, it usually turns out that this acceleration in the y direction, it isn't always the case, this is some value. When we talk about things moving on the Earth and y is up and down, this is typically 9.8 meters per second squared on the Earth. If it's on Mars, it's another number. This typically is 0. There is no acceleration to the left or the right if you're having something in a free fall problem. We'll do free fall problems. And then that changes the problems. Like if you know this is always 0, it makes the problems quite a bit simpler. So you have to do the problems separately. So you have to use these equations. And then notice these are all x equations, right? Right? I could rewrite these equations, put them right here, and they would be the y equations. But they're exact same equations, except we change the x's for the y's. So now you're not going to do any problems necessarily in class that face this, but this is coming, and this is super important to understand that these equations have to be dealt with separately, all right? Solve for the x, solve for the y. Because what's going to happen, let me just sort of give us sort of an example. If I have an object, let's say we know the velocity, this is the velocity, is moving at, say, 10 meters per second. But this is at an angle, right? So what I have to do is, and let's say that this is at a 45-degree angle, what I can do, well, actually 45 is too easy because then it's the same number. Let's say this is a 30-degree angle. So if I know this is a 30-degree angle, I have to find what the Vx is here and the Vy is using SOHCAHTOA stuff, right? Using trigonometry. I can find the Vx and the Vy. One will be sine, one will be cosine, right? This is the angle, this is the opposite, this is the adjacent. So this will be using, so the y would be sine, right? It'd be, yes, sine, opposite over hypotenuse. You would say, you'd say sine of 30 degrees equals Vy over 10, because 10 is when you like launch a ball up, at a 30-degree angle, and that would give you do the math, solve for Vy, and for the other one you'd say cos 30 equals Vx over 10. You get a slightly different number, and those numbers go in here when you solve the problems. So, big message, big message. When you have two-dimensional motion, all right, you need, or even three-dimensional, what you have to do is you have to deal with them separately, but the connector is time. Houston, we don't have a problem.